From Unit 8, logarithmic functions and exponential functions, and it's the second day in the unit. And today we're going to focus on going back and forth between log and exponential functions. So a log is a new term for you, and just remember that a log is an exponent. So let me give you an example of this and see if you can first figure this out without me actually telling you what the answer is. So write down these three examples, please. So there's three examples. Again, I haven't even told you what this log function is or how it works, but I'm going to actually give you the answers and give you just a little bit of time working with your partner to see if you could figure this out. So for this problem, x equals 4. For this problem, x equals 2. And for the last example, x equals -2. So somebody in my third hour was able to come up with this literally within the first minute, maybe actually within a few seconds. With your partner, see if you can figure out, knowing that logs are a part of exponents, okay? They're intertwined. See if you can figure out how the heck do we get an answer 4 or 2 or -2 with these problems. I'm going to give you a minute with your partner. Go. Fernanda, you haven't taken your shower? Okay, you guys ready? So who, by the way, thinks they've caught on to it, the idea? So, you ready? I'm not going to tell you if your idea is right. Here's what I want you to do. I want you to tell me, based on your idea of it, what is that answer? That means, what does this equal if your idea is right? So if I make this an x, what does x equal if you think your idea is right? I know Spanish. 3? You guys agree 3? Okay, David, can you give me an idea of how this works? So let's go to the first one. You're so close. You're so close. Diego.
Never mind.
I heard when Daniel was speaking with Pedro, I heard Pedro, I never heard what Daniel said, but I heard Pedro describe it correctly. Pedro, do you want to take a guess?
I said it's whatever. What does 4 to the what power equals 16?
Yeah, so it's 4 to what power or what exponent equals 16? 2 raised to what exponent equals 16? 5 raised to what exponent equals 125? So let's go down here. 3 raised to what power equals 27? 3. Okay, so this is called logarithmic form. Logarithmic form, okay? And when you put it into exponential form, it looks like this. These are equivalent forms, just like 1/2 is equivalent to 0.5, or 4 divided by 2 is equivalent to 2. The equivalent of this in exponential form is 2 raised to the x power equals 16. 4 raised to the x power equals 16. Bless you. 5 raised to the x power equals 1/25. Please write those down. So 2 to what power equals 16? The answer is 4. 4 to what power equals 16? The answer is 2. And this is a little bit more difficult. So I need to turn 5 somehow into 1/25. So first think of it this way. Do you agree that 5 squared is 25? But I don't want 25 to be on top. It needs to move to the bottom. So that exponent can't just be a 2. It needs to be a Negative 2. Hands up high if you're kind of understanding the concept. Okay, so that's what we spend the first 20 minutes teaching in the PowerPoints, okay? So we're going to practice more of them together, and we're going to make them more difficult. So the first thing is how do you even say this? So let's write down the first one. This is log form. This is the equivalent exponential form, so I'm just going to abbreviate. Oh, I messed up the color coordinating. Okay, so how do we say that? This is read as log base 2 of 8 equals x. Log base 2 of 8 equals x. Joseph, can you give it a guess? You've seen this before. How would you say this? It can be said in different ways.
2 to the x power equals 8.
Totally works. Yeah, he said 2 to the x power equals 8. That works. But this is the one that's new to us, being a log function. So it's log base 2. The base is down below. The base, this 2 is not at the same level as the 8. This is not a 28. It's a subscript down below. So log base 2 of 8 equals x. And these are equivalent forms. Please write these 3 answers down. Son, so do we describe these 4 examples as being right now in exponential or logarithmic form?
Exponential.
Good, these are all, and I'm just going to abbreviate, these are all in exponential form. And now what I want you to do is I want you to write them in log form. So I don't want you to go ahead and try all 4 and have it incorrect. So let's do the first one together. Now when I first teach this, and if you'd be looking at the PowerPoints, I use rectangles to represent where the numbers will be placed. So the base here will remain the base over here. So the base of this number is, or the bottom number is 3. So this 3 goes into the same place over here. Remember, one of the first things you wrote down in your notes was log equals exponent. So here's your exponent, log equals exponent. This top number is always going to go on the opposite side of the equal sign. And the answer, the final answer, is going to be behind the base. In this case, it's 1 over 27. Yes, it should be. Thank you. Who pointed that out? Nice, Ben. Thank you, Benjamin. Get the same color so that shows up. Okay, please do the next 3, and you don't have to use boxes if you don't want to. Go ahead. Okay, ready? Anna, give it a try. How would I read this? So as you read out loud, I'm gonna write it down. You can't see that well. Will it help you if I zoom in? So how do we say it? Log? What word is she missing? Okay, so go ahead. Yeah, you got it. So log base 36 of 6, keep going, yep, equals 1/2. Log base 6, sorry, log base 36 of 6 equals 1/2. Now, several students are like, I don't get that, it's confusing. Remember, when I gave you this, so let's come down here and write this down. If I gave you this, what is the answer? 5. Remember, what number is hidden right here? A 2. So if you write this not in radical form, but in rational exponent form, it's 25 to the 1/2. That 1/2 simply represents a square root. So do you agree the square root of 36 is 6? Yes. That's what this is saying. Okay, next one. Let's go ahead and let's go with Nick. Read for me.
Log base 49 of 1/7 equals 1/2 or -1/2.
Nice job, Nick. Log base 49 of 1/7 equals -1/2. So do you agree the square root of 49, that's what this means, do you agree the square root of 49 is 7? And because 7 is now on the bottom, we make it a negative sign. Very last one, Robert.
Log base 3 of 81 equals 4.
Nice job. Log base 3 of 81 equals 4. On a scale from 1 to 5, how well are you understanding going from right now, I give you exponential, you rewrite it in terms of log? Hands up high, 1 to 5. Okay, let's just practice a few more. We're going to do 2 more. This time I'm going to give you the logs and you rewrite them in exponential form. There's the first one. Please rewrite it in exponential form. And rewrite it in exponential form. Okay, you ready? Let's have somebody that I've not called on. Let's go with Isaiah. Can you give me what you think this is the equivalent to in exponential form?
6 raised to the negative 3 times.
Equals?
160.
Did you say 1 over 216? 1 over 216. 1 over 216. So, yes, 6 raised to the 3rd power is 216, and then it has to go on the bottom. That's why this is negative. Giselle, very last one. There we go. Nice job. Okay, again, 1 through 5 if you understand the first learning objective. Okay, we only have one left, and that's can you evaluate these with and without a calculator, and why the heck have we even learned about logs? So let's first do it without a calculator. Take your calculator, flip it upside down. Daniel, can you watch Pedro? Sometimes he tends to want to use a calculator, okay? Thank you. You do not have to write these down if it's just practice for you. Raise your hand if you know what this equals. So when I say evaluate, I just want an answer. So, Diego, I want 2 things. I will not tell you if you're right or wrong. I want to know, first of all, what do you think the answer is and how did you get it? And then we'll talk about it as a class if we agree or disagree, okay? Okay, Diego, what is the answer?
I believe the answer is 3.
Okay, hold on. You believe the answer is 3, and why is that?
Because in my mind, I rearranged it to 5 to the x power is equal to 125, and I figured that it would be 3 because 5 times 5 is 25, and 25 times 5 is 125.
That's a great processing in your mind. So he said in his mind, he rearranged this so 5 to what power equals 125, and he knows 5 to the 3rd power is 125, because 5 times 5 times 5 is 125. Yes, Pedro?
How would the inverse operations be done?
We're not going to get to those 2 tomorrow, and that's going to be the learning objective number 6. And when we try to find inverses, we'll talk about that, okay? Because you're going to learn something new, okay? All right, here's your next one. Now, for some of you, writing this on paper for this one is going to be helpful, just so you know that. For some of you, it will be. Benjamin, what do you think? Okay, can you tell me how you came up with 1/3? Diego? And now you're right, but there's still gonna be people that are like, I don't know how you get 1/3 of that. Like, I understand how you did this, but how do you end up with 1/3? So can you keep explaining the math behind it, Ben? So he's saying I could rewrite this like this or like this. And if you're still confused, think of it this way. What times itself? How do I break 27 back down to 3? So what number am I going to take times itself 3 times in order to get there, right? So that's how we're going to get to our 27. Okay, nice job. Here's your next one. So I'm going to make it a little more difficult because you guys are doing so well. I'm going to challenge you. No calculators can be used right now. Okay, ready? Itzel, do you have a guess?
-4.
She believes -4. So, Itzel, can you tell me how you came up with -4?
Oh, because it's not happy, so you have to move it towards the bottom.
Okay, so I'm going to rewrite it like the boys were talking. So it looks like this, correct?
Yeah.
So if you put this in, so what I hear you saying is that 16 raised to the -4 power should equal 1/2. And the 16 becomes a 2 on the bottom because it's negative. But is 16 to the 4th power equal to 2?
Shouldn't it be -1/2?
That is great. This is a difficult problem. Okay, can you please turn and talk to your partner to better understand how do we get an answer of -1/4 as the final answer? And I'm going to see if I can re-explain it to you.
What if there was an X there?
So that could be an nth root, it could be any number. Let me think about that.
Wouldn't it be like a number to 1/x?
Can we go over that a little bit later? We're gonna solve that a little bit later, but I have to think of it in fractional form. It would be like, I know if it's not a fraction, okay? That's what we're gonna get to when we start doing this unit. Okay, you ready? Here we go, guys. Here's how I personally think of it. So you ready? 2 times itself, how many times equals 4? So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is? So that's 4 2s. Does everybody understand? That's your 4, and then it has to go on the bottom because the 16 and the 2 are at different levels. Done. That's how I think of this. So if I go like this, log of 125 and 1/5. So log base 125 of 1/5. So myself, I think 5 times itself, how many times it gives you 125? So 5 times 5 is 25, 25 times 5 is, so I know it's 3, but then they're at different levels, right? They're at different levels, so it's going to be a -3. Now, let's go back here and talk. It still needs to be not just a -3, but a -1/3. 125 raised to the -1/3 equals 1/5. I like it, Diego. I like it. Okay, we're almost done for today. Let's do this one. Evaluate. And then we're going to go on to our last concept before we finish up. Servando, can you help me out? What do you believe the answer is? Okay, you ready? So I need to go from a 2 raised to some exponent equals 127 or 128. So let's do it in our fingers. Ready? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64, 128. So the answer is 7. So I'm going to come back and help Servando out. What do you do when you can use a calculator and you're not figuring this out? Okay, we're going to come back to that in a second. Here's what you do. Please write down change of base formula.
Wait, we were not to use a calculator?
No. But when you take an SAT, an ACT, an AZ Merit, you get to use a calculator, right?
Yeah.
So we're going to learn both ways. So change of base formula. Your current calculator is set up on base 10. It is always going to be set up on base 10. Is this a base 10 problem?
No.
What is it, a base 2? So let's pretend you are Servando and you're like, I don't know the answer. Well, if it's not a base 10, then you get to use the change of base formula. How this works is it does not matter what number is bigger or what number is smaller. You're working on the back number. At the same time that I'm doing this, please type in log of 128, enter. You'll find the log key next to the number 7. So log of 128, enter. Then we're going to divide it by the log of the base. And for this particular problem, it was 2. Final answer, 7. Done. Does everybody get that? Does anybody want me to repeat the instructions again?
Please.
Okay, so please do log of the back number, so log of 128, enter, divided by the log of 2, enter.
Okay.
Okay, so I have 3 things to get through, and I can get through them in the next 3 to 4 minutes. Okay, here's the first thing. You ready? So if I told you 2 squared is 4, which you guys know, right? Number line. Here's 5, 6, 7, 8, and 2 to the third is 8. You guys agree with that, correct? Well, if I said then that the log base 2 of what equals 4? What is the answer here? Log base 2 of what is 4? 2. And if I said log base 2 of 8, what's the answer? 3, right? 2 and 3 so far. So this is going to be an answer of 2 to the second power equals 4 and 2 to the third power equals 8. Well, what if I wanted this one? Log base 2 of 6. I know it's going to occur somewhere in between 4 and 8, and I know it's going to have an exponent of 2 to the x equals 6. So I know that x will be between 2 and 3. I just don't know exactly where it's going to occur. You're going to get an irrational number or an ugly decimal. So using this function, the log function, we can accurately evaluate this equation. So please do log of 6, enter, divided by log of 2. And we're going to have to estimate. And if I remember right, you guys are helping me out. What is it?
2.5849.
Okay, 2.58 something? Okay. So there's 2 other rules I want to go through with you. And they're basic rules of log functions. Here's the very first one. Actually, there's 3 rules. Here's the first one. Log base, I'm going to write C of C will equal 1. Assuming that C is greater than 0, it's a positive number, you can take log base, let's say 7 of 7, it will equal 1. A log base 11 of 11 will equal 1. Because what that means, 7 raised to the first is 7, true or false? And 11 raised to the first is 11, true or false? So when these, here's the cool thing, here's how this works. When these 2 numbers are exactly the same, we wipe it out, cancel out, and put a 1 in place. Cancel out, put a 1. So if I said to you, reduce this, let's just make this up. Reduce this, what does that reduce to? 1. And the reason for it is because 9 raised to the first power equals 9. So that's your first rule. Your second rule involves a 0. So what is, no, let me just write it down. C can be any number that is positive. So if I use 3, log base 3 of 1 equals 0. That means 3 raised to the 0 power is 1. Well, in fact, any positive number raised to the 0 power is always 1. Log base 10 of 1 is 0. True, because 10 raised to the 0 power is 1. Sometimes there's a misconception that if you raise something to the 0 power, you get 0. Not true. If you raise a number to the 0 power, you end up with 1. Positive number raised to the 0 power is 1. That is your second one. And here's your very last concept to go over today. Let's write this one down. If I asked you to solve this, so we want to know 2 raised to the what exponent equals negative 3. And there's multiple ways for us to show this or to achieve the answer. 2 raised to what exponent equals negative 3? So is 2 to the 0 equal to negative 3? 2 to the 1 equal to negative 3. What is 2 to the negative 1? When you raise something to the negative, it flips it and makes it 1/2, right? Do me a favor, do second plus 7 to 1 too. Set this equal right now, please. Make this an x, set this equal to L1, set this equal to, I said L1, I meant Y1. Set this equal to Y1 and Y2 and tell me where they intersect. They do not intersect. So if they never intersect, what is your answer? No real solution, okay? We'll pick up tomorrow.